Last time we were looking at data input methods, and I actually ended up with how to detect errors in a code, and the modulus 11 check digit is one which is normally used, and we looked at the theory of why it is modulus 11, and we also saw that it is an alphanumeric code that has both letters and digits. Then it is modulus 37 system which you use. Okay. That is depending upon the total number of symbols, like if it is hexadecimal, the next higher prime is 17, and you use 17 as the modulus number. So the method was to actually add a digit in such a way that when you multiply the rest of the digits by distinct weights 2, 3, 4, 5 and so on, and divide by 11, you will get a remainder, and that remainder is one which is used as the added digit. And later on, if there is any error, there is either single transcription error or single transposition error, then that will be detected. And we also said that 95% of the cases it is either single transcription error or single transposition error. And in those which are left out, also almost about 90% of what is left out are detected, even though you cannot guarantee detection. And so that is a very simple method which is used in many situations, particularly if you look at a practical example. All books will have what is known as a ISBN printed in the copyright page. ISBN stands for International Standard Book Number, and that has got actually it's a code which has got total of 10 digits, and it uses a modulus 11 check digit as the last digit. You can just check it, take any book and see if it satisfies the modulus 11 check system or not. The ISBN is again some kind of a block code, except that it is instead of using characters for for easily explaining. In other words, it is less meaningful than a normal code with characters in it, but it is in certain types of fields, like there is a first 3 digits are used for country code, and then the next 3 digits are used for the publisher within the country, and the last 4 digits for a serial number of a book published by that publisher. So then of course one more digit is there as a check digit. This is the way it is actually formulated. Okay, and you could just check it up, and that is an interesting example of a standard code used all over the world for book numbers, that is giving a unique number for every book published in the world. That is what it is supposed to be, and those publishers who register for that system automatically get all data except of course the serial number, which he adds as in when he comes up with a new book published, then he adds it and goes to the next serial number. The last 4 digits are there for the serial number. Okay. Now apart from the error detection, when we also pointed out that when there is a large volume of data as input, special precautions are needed to validate the data, because if the number is extremely large, like lakhs, like in CET exam or any other board examination and so on, there is extremely it is extremely difficult to ensure that the data entry operator will not make any error. There is every possibility of the data entry operator making an error. Sometimes it is also possible for a data entry operator to be mischievous. In other words, he may change some marks intentionally, and one should essentially guard against such fraud. and there also it's very essential in any kind of a system to guard against fraud. Like for instance, if we changes 59 marks into 95 marks, then of course obviously it's intentionally done. Of course, it could be done accidentally, but whether it is accidental or intentional, it is a duty of the checking program which checks the input data that such errors are detected and corrected before it is stored or further processed by the machine. So, there are a number of checks which are normally used to make sure that in any batch of data which you enter normally manually in such large systems, there are checks and balances, you might say. So, the validation checks one is to put sequence number for each record, so that you count the total number of records and you do not ever input all records together. So, what you would normally do is give a sequence or serial number from 1, starting from 1 to the end, which may go up to something like more than 1 lakh. But when you give it to data entry operators, there will be more than one operator to whom you would have given that divide up the job and give it to a number of operators. They all will work in parallel, so that the work will be done faster. So, you may make batches of something like 50 manageable batches. So, serial number 1 to 50 you give to operator number 1, 51 to 99 or 100 you give to another operator, and 151 to 100, 101 to 150 and 151 to 200. That is the way you kind of divide up into batches of 50 you might say. Okay. And for each batch, see, the advantage of serial numbering is that when a batch is entered, the program also counts the total number of entries made and checks against the total number which you also manually write. That is, in other words, apart from the data itself, there is one more data item called a batch control data, which occurs at the end of the batch of 50. So, in that batch control, you put the total number of items in that batch. If there are 50, you enter 50, and then there are some other checks you do. For instance, you manually add all the marks in a column, okay, and when you add all the marks in a column and put that as a new number, and when the data entry operator enters, then the computer will actually add all the marks in a particular column and check it against the total which you have put in the batch control, okay. And so that if there is any kind of an error or any mischief, it will be brought out by the control total, okay. So, the batch control totals does the serial total number of records in that particular batch, and also certain checks like say certain fields are taken and the total number of items in that field is added and given. For instance, in examination where ABCDs are given in subjects, so what you could do is that at the end you can say total number of A's is so much, total number of B's is so much, C's is so much, D's is so much, and F's are so much, and then you can actually count it by a program and count against the manual number which is written by the person who creates the batch control, okay. Because batch control, one should make sure that the batch control is not tampered with in any way, and if there is any problem, one should also be able to track down from the batch control total that which particular batch this error occurred, and then you can pinpoint the particular operator who entered it, so that you can, if there is any suspected fraud, you can investigate it. This is called an audit trail. That is, you got a method of trailing who did the mistake and whether it is intentional or is accidental. And So batch control total is absolutely essential. It is always used in any large data entry to have smaller batches and have batch controls. And batch controls, actually the control line is manually calculated, okay, and it is put there. And sometimes that particular in order to eliminate frauds, that particular total may not really be known to the operator who enters that data, so that somebody else can enter that and entered data can check and so that the total can match. In other words, the point I am really making is suppose the operator knows that the control total is being taken on a particular say field, say for instance physics marks, and there is 195 and 159, and he may intentionally interchange these two marks, in which case the total will remain the same and no error will be detected. So in other words, the person who is entering and the person who the program which is checking are the same. In other words, the person who is entering knows that this total is being done and the total is being checked. So in other words, so it doesn't provide security. So what you should really do is that the total should be separately calculated and kept with you, with a supervisor. And then after the data entry operator enters all this 50, then you check it against the control total, okay, by a program. And if there is any kind of a discrepancy, then you can track down, in fact either manually or by means of a program where the error occurred. And if you suspect fraud, of course you can have an audit trail, that is who entered this, okay, and that's the way in which it is normally carried out, because it is the entry operator does not know which particular marks column is being added, because it could be physics, chemistry, mathematics, and you may randomly decide that one batch you add physics marks, in another batch you add chemistry marks, and so on, okay. So in other words, if randomly it is done, then the operator does not really know which particular field you have added, and he may even not be told at all about the control total being kept there secretly without his knowledge, so that any such fraud can be eliminated. So batch control totals are very important. And there is another data entry and verification which is very expensive, but in some very important situations where any single error in a data entry could become fatal to the application, you in abundant caution you do this. In other words, you have two different people enter the same data, and that means it's duplicated, and you actually do a verification of the entered data by means of a computer program. The computer program, because two independent people have entered the same data and the person does not know who is the other person who has entered it, there cannot be any collusion. So any kind of fraud will easily come out if verification is done by complete duplication. But of course it is expensive because it doubles the work. The same work is being done by two people. The other kind of a check is called record totals. The batch total is for taking items in a particular field of a record and adding all of them for the particular batch. A record total may be the total of certain random fields in a record added and put at the end of the record, okay, and that can be a separate control which can be checked after the data is entered. So total is record total tells you, identifies which particular record the total does not match, and so you can actually track back and get to that record where it doesn't match, okay. And of course modulus 11 check digit is for key fields. Key fields, if any error occurs, modulus 11 check detects them, and guaranteed detection in 95%, not so guaranteed in 4 or 4%, almost 99% of the cases the error comes out the modulus 11 check. There is also other methods which are used earlier, but they are not as good as modulus 11. One method is just to add the digits of a code and take modulo 10, and that is very easy to do. That means all the weights are equal, and then you just do addition and modulo 10 you put the number, and that can never detect single transposition errors. It in some cases it will detect the single transcription error. So normally the even transcription error it will normally detect, because the sum will be different if a different number is used. But if suppose two different digits are the same, and then both of them are changed, then of course it will not detect it. Okay. So these are problems with modulus 10, but it is a very easy method. But nowadays it is not very commonly used. Modulus 11 is not more popular. Now there are checks also on individual fields of record, which you normally carried out. One is called a radix error. For instance, suppose you are entering minutes and seconds, hours, minutes and seconds. Then the hours cannot exceed 24 if we are on a 24-hour clock. Minutes cannot exceed 60, seconds cannot exceed 60. So we can actually check if an incorrect entry is made, then immediately it will throw it out, saying that it's a radix error. Similarly, for instance, date, for instance, there is a date field also. It's a kind of a radix error. In other words, the number of months in a year cannot exceed 12. So it has got to be number less than 12. The number of days in a month cannot exceed 31. So that is an error which you can find out. So it is one of the possibilities of detecting errors in dates. Dates and times are simple examples of what are known as radix error correction. Range check. Range check is fairly straightforward. Normally, if you are entering marks, then the marks will normally range between 0 and 100. If 100 is the total marks in that particular subject, 100 is the maximum marks. Normally, marks cannot be negative and marks cannot be greater than 100. And so if there is a proper range check, then any incorrect entry of a number above 100 will be detected and thrown out. Okay, and so that is called range check. And they are very easy to kind of include in any program while the data is being entered. So a program, as soon as the data is entered, a little program kind of looks at the data and takes out the obvious errors like radix error or range check. There is some also called reasonableness check. Reasonableness check, for instance, is a little bit more complicated. Suppose a person has been getting telephone bills which are normally say 1,000 rupees a month. Suddenly 1 month he gets a bill for 10,000 rupees. It is obviously possibility of mistake. So you go back and check that. Don't send a bill of 10,000 rupees to the person immediately. There will be a furor. In other words, there are in fact news items in newspapers you would see that somebody got a telephone bill for 2 lakhs rupees suddenly. Okay, and then it becomes a news item, and it kind of reflects very badly on the billing program of the telephone company, saying that a person who is normally paying 1,000 or 2,000 rupees a month ends up with something like a lakh. You expect there is some obvious error is there, or if it is not, then you should actually go back and check why it became 1 lakh. So these are important for the supervisor of after data entry to check these things. A program can check it right away. A program can check it by looking at the average bill and the bill of this month, and if it is unreasonably large, it can just throw out that record for manual inspection by supervisor. Inconsistent data, like for instance 31st April, because April has only 30 days, so it cannot be 31, okay, or 30th February, it can be either 28 or 29 and then not 30. Most date checking programs are built in, and many, because it's used so often that you have a little function to check the date. And in fact, there is one exercise which is always given in computer programming courses, okay, including the leap year checking and so on. Incorrect data is found out by batch total, the batch control total. Missing data also the batch control, because the serial total number of items in the batch is counted, and if it is a missing record, then the count will show you that instead of 50 there are only 49, okay. Or if it is one more extra, 51 instead of 50, then that means some incorrect data has sneaked into it, so then you recheck it, okay. And something called interfield relationship check, that's also interesting. There is interfield relationship check. There are a couple of examples I will give. One example, for instance, would be that suppose that a student takes about 5 subjects in an examination, and he gets in physics 99 marks, but in mathematics he gets 10 marks. Then there is a interfield. When you compare these two, then you don't expect a student who gets 99 marks in physics to get 10 marks in mathematics. So obviously there could be an error, either in data entry or in marking or whatever. So this kind of an error should also be thrown out at the time of data entry, so that detailed check can be made, and not send a mark sheet to the poor student and then ask him to go from pillar to post and pay money for rechecking and stuff like that. It really reflects very badly on the data processing system and the contractor who was employed by the university or the school board or whatever it is, to not check these things and put the student to a lot of inconvenience. As a responsible systems analyst and programmer, it is your ethical duty to make sure that these stupid, silly errors do not occur. And if it occurs, it reflects very badly on your professional competence. And it seems to be occurring again and again and again in our country, because we always hear about so many students having to go back to do a re-evaluation or rechecking and total checking and stuff like that. That shouldn't really be happening, okay. But of course sometimes it may be real, the student didn't do too well. Most often, so a case like 99 marks in physics and 10 marks in mathematics, most often there is an obvious mistake either in data entry. Maybe he got 100 in mathematics and the person entered only 10th, and obviously this is a very bad thing to happen, okay. And similarly, another example is if you have an age of a student and the class in which he studies, normally a student in 8th class cannot have an age greater than 25. I mean, exceptional cases may be there, but if it turns out, then you have to kind of do a manual checking. So in this particular module, we looked at primarily the various methods of data input, and we also looked at the importance of the correctness of inputting data and methods of detecting errors in data entry, because in any large volume data entry, errors do happen, and it is the duty of a systems analyst to make sure that at the time of system design he or she puts in controls, appropriate controls, to eliminate such situations. Now we go on to the next module, which is on logical database design. The reason why I am going there now is, so far we have looked at data flow diagrams, we have looked at how to enter data. Once the data is entered, the data has got to be stored in some database. See, what goes into the database has to be clean. In other words, if there is any error in the data which is entered in the database, later on you will get into difficulty in terms of when you process. So before anything gets into a master database, it is essential to make sure that the data is cleaned up. And clean data, you might say laundry, you must do a laundering of the data before the data gets entered into the database. So the database organization presumes that the data which is going to be entered is correct in terms of there are no errors in data entry and stuff like that, and further processing can proceed. And primarily in this the module, we will look at what is commonly known as a relational database system. Relational database system is now very commonly used. In fact, it is might say de facto standard used by every organization. So relational data, is a relational. I will explain what is relations and why it's called relational database. Okay, but before we start or create a relational database, we have to kind of model the data, and there is something called an entity relationship modeling of data, which we will learn about, and how to organize data as relations, and normalization of relations. Normalization I will explain in great length as we go along. Creation of logical relational database. Logical database is something which is you have to make a distinction between a physical database and logical database. Logical database is something which you create to understand how the data will be organized. A data has to be ultimately stored in a physical device like a disk, and there is something called a database management system which transforms logical database and stores it as a physical database, and while storing as a physical database, it should make sure that the physical database is uses the best possible economy. In other words, make sure that optimization is done in the storage so that retrieval will be fast and things like that. And we will not get into great details of database. DBMS is database management system. The reason we will not go into great detail in this particular module about database and relational database management systems is because in any computer science curriculum there is a full course on database management systems, which will be compulsory in almost all universities, because it's a pillar or a cornerstone in the learning of computer science and engineering. So database management system is a very, very important course, and because a whole semester is devoted to database management system in this series of lectures, I cannot really afford to, it is not a purpose to be able to cover the entire subject. Purpose here is to give you a flavor of what database management, what is relational database, why is it important, how it kind of give an idea of what DBMS is. So it will form a proper groundwork for you to study further. Okay. So this, you might say, the foundation on which you can build later on in your other course. So this module will learn entity relationship modeling, to develop a conceptual model of data, how to organize data required in application into relations, the need for normalizing relations. I will tell, because very often students don't understand what is there are a number of issues. One is, what is normalization? Why do you normalize a database, and how do you do it? Most often students know mechanically how to do it, but they don't understand why normalization is required. So one of my major objectives is to essentially talk about, first, what is normalization, why is it required, and how it is done. And there are a number of normal forms, and each one is relevant in certain situations, and we will say which form is relevant in which situations. So how to normalize relations into successive higher normal forms? There are a number of normal forms called first normal form, second normal form, third normal form, fourth normal form, fifth normal form, and so on. So in fact, every few years somebody comes up with a n+1th normal form, but very often in practice people are quite satisfied with going up to third normal form, because for all practical purposes 3 normal forms is sufficient. Beyond that, in pathological cases you go. So I will emphasize more up to the third normal form in this lecture. The need for an integrated database in organizations, that is an important question which will be raised, because a relation is relations really are components of a database system. A database will consist of many relations, and all these will be managed by DBMS, okay, and structure and organization of DBMS. So when a DFD is developed, we have knowledge of all data elements required by an application, okay, and dictionary lists all data elements but does not say anything about relationship between data elements. In other words, only the data DFD, at the end of it you come up with a data dictionary. As I said, data dictionary is more to really have as a documentation aid for a programmer who is going to maintain the program, to understand the meaning of a data, where it occurs, and so on. So the maintenance can be easy, okay, and it lists everything. It's a data dictionary is actually a metadata, data about data, okay. And for logically organizing groups of data elements, relationships between data elements are to be known. The relationships are not really available in the data dictionary. It's only a listing of all data. So the last point, namely relationship are needed. What is relationship? And that is what is important. There is relationship and relational method of organizing reduces data duplication. Okay, simplifies adding, deleting, and updating data. Simplifies retrieval of desired data. In other words, why should we do a relational operation? That is the motivation. So if you do a relational database organization, it reduces data duplication. If you duplicate data, it's unnecessarily, storage is wasted, and also if there are duplicates, there is a possibility of the two so-called duplicates can be inconsistent. Okay, so one should not have inconsistency. Okay, and you should be able to add, delete, update data without any errors. In other words, if you delete something, you may unknowingly delete some important information about some other item. Okay, that is what is eliminated. Similarly, when you add something, it might be inconsistent with what already exists. And when you update, you may make a mistake in update. And all these things are really what are detected, or ensures that the relation database system ensures that these things don't really happen. It simplifies, and also it simplifies retrieval of desired data. So, logical database give conceptual model. Logical databases need to be stored in physical media such as a hard disk. I told it already. A system is needed to map the logical database to a physical medium which is transparent to an application programmer. In other words, application programmer should not be worried about how the relations are actually mapped into a hard disk, because a hard disk, as you know, are organized into number of cylinders, number of sectors, and so on. So, sector organization, the cylinder organization and so on should not be of any concern to the programmer. How it is mapped is the job of the DBMS. As far as the programmer is concerned, he looks at the data as a logical data for all the programs he writes. Okay. So, this is what is important. That is why, as far as the program is concerned, the actual physical organization should be invisible, unknown to him. Okay. And DBMS, database management system, achieves this purpose. So, as I said, the purpose is to develop a conceptual model of data. This model specifies relationships among data items. Using this, raw data is organized into tables of related data. So, a table of related data is really what is called a relation. Okay. In fact, I am being very loose in my definition here, but I think it is a more strict definition will be given as we proceed. The tables are organized in such a way that duplication is reduced, operation of adding, deleting, changing data is simplified and systematized. Of course, the systematization reduces accidental errors. Retrieval of data is facilitated, just repeating what I said. So, collection of these tables is called a database for the application. Loosely, one may call organization of related data items put into a table as a relation. The reason I am calling it loosely is because there are lots of other, there is a huge theory of relations which is there in the literature. There is a person known as Codd, CODD, who first invented this idea of relational database, and you had what is known as relational calculus, which could be applied to this. And in some sense, it is somewhat like the relations in mathematics, relations, functions, and so on. They have very specific meaning in mathematics. So, similarly, he used very specific mathematical definitions, and which are not as loose as I am making it out to be. They are a lot more stricter, and they are the ones, theoretical foundation on which the entire relational database idea is based. So, the reason why it is so popular is because there is sound theory of relations underlying this concept, and which ensures all these ideas of simplification, non-duplication, elimination of inconsistency, all those things are part of that mathematical structure which has been made up by the person who proposed the relational database idea. As usual, some of the ideas when they are first proposed are not immediately accepted, because it turned out that when first proposed, it was a little profligate, or in other words, did not economically use storage, because it was actually proposed in the 60s. At that time, disk storage was as a premium. The largest disk available in the 60s was something like 20 MB. Today, of course, no self-respecting person will have a PC less than 80 GB. So, now storage has become very large and at very low cost. So, the so-called uneconomical method of storing is no more relevant. So that's why when computers improved, slowly people realized the importance or ease of using relational database, and so other methods which are prevalent earlier were all kind of abandoned, and relational database is what is currently being used as a standard by almost everybody. Systematization by which related data are put in a table is called normalization. A method called entity relationship analysis is facilitates creation of relations. So how do you create relations? In order to create relations, we use a modeling tool called entity relationship method. And again, this is proposed by a person called Chen again some years ago, and I will effectively, it is a very simple idea, and the idea of entity, which again and again occurs in computer science. Later on, the same idea of entity will occur in object oriented design, which will come later in this course. But so the question is, we have to define what is an entity, we have to define what is a relationship. Entity specifies a real world item in an application. In other words, it's something which exists as either animate or inanimate. Okay. Normally, it's some kind of a noun phrase. Say. Examples are like vendor is an entity, an item is an entity, a student is an entity, a course is an entity, teacher or teachers, teacher is an entity. So there are entities. Normally, these entities are the ones. There are many entities in a particular relation, and those entities are related. And we have to talk about relationships. Relationship is a meaningful dependency between entities. For example, a vendor supplies items. So vendor and items are entities, whereas supplies is a relationship. In other words, it connects the two entities, namely vendor and items, through the relation supplies. One way of looking at it is the vendor and items are nouns and supplies is a verb. Okay, and normally relationships are verb classes, and entities are noun classes. So teaches courses. So teaches the relationship, and the two entities which are related, namely teacher and courses, is by the process of teaching. Okay. So here you underline the relationships. Entity set is a collection of similar entities. There is suppose you have a collection of records, or for instance, when you take a data flow diagram, you take the vendor as a key item. Okay, vendor code, say. But there are many vendors with different codes. Set of all vendors who are supplying items to the organization is a vendor set. Okay, because where the elements are entities, as individual vendors are, you might say, members of the entity set, and they are all obviously, as you know, in a set, the members all have a common property. Okay, a set is consists of a number of similar items. So you might say set of chairs, set of tables. Similarly, set of vendors. Set of all items in a store, okay, is an item set. See, it's normally entities are members of a set. Like a teacher is a member of all teachers in the university or in the college. Okay. So every member of an entity set is described by certain attributes. There is if you take a vendor, the vendor will have certain attributes. Like, for instance, vendor will have a vendor code, because I said you had a unique identification for any particular entity, and I have put in boldface the key field, you might say, or the unique identification of that particular entity. Because the entity has got the attributes, namely vendor code, vendor name, and address. Okay, these are the three important attributes of a vendor. Okay, and his name and address. Okay, and supplies will have it relates two different entities. So the attributes will have both the entities which take part in the relationship between vendor and item. So there is a vendor code and item code are both given in boldface to indicate that the relationship supplies actually connects these two. And the attributes are you have ordered certain number of items from a vendor, and normally it is an order number, which again order number is an identification of the order, which is a unique identification. So order number, quantity supplied, date of supply, price per unit. These are all attributes of a relationship. Some more examples. A teacher. Teacher is an entity. Teacher code, teacher name, department, building, room number, phone number, maybe home address, whatever. See, you may really put all the important information about a teacher in that attributes of a teacher, and you will put that information such as address if it is important in the application. If the address is irrelevant, like in this case the phone number is given, you assume there is an office phone number. There also could be a home phone number. If it's a home phone number, then it's a residence number and office number. Okay, they both may be given. Okay, so it depends. The attributes which are important are decided by the application to which you are going to put this entity. If you are going to be sending, say, some letters to the teacher at his residential address, then the residential address becomes an important attribute of teacher. Similarly, if you want to be able to phone the teacher at home outside hours, then the phone number becomes important. So the point I am trying to make is there is no hard and fast rule about what attributes to put. You will put the number of attributes depending upon the situation and the what application or what future application you are going to use this for, this entity for. Because as I pointed out, has been pointing out continuously in this course, software systems had to be designed for expandability and flexibility. Expandability is an important part because no software system is ever static. So even if today you feel that home phone number may not be required, tomorrow some policy of the institute or university may change where a home phone number may be required. You don't want to go back to the drawing board and start redesigning your database at that time. So it is kind of better to look a little bit ahead and see what are all possible uses may be put in the near future at least. And in this you can get some help from the user, the person who is actually asked you to design. But as I said, a good analyst or a good company will teach the analyst to kind of put some of these things. It may be considered redundant today, but it may be a great help tomorrow. Okay, so one never knows. So it's better to kind of look at the possibility of expansion. So relationship is a teacher, teaches. See, teacher is an entity, teaches is a relationship. So if you want to have the attributes of the relationship, there is a teacher code and course number. Course numbers are also unique in any university. Okay, the course name is there, but course number is the one which is very commonly used in almost all universities, at least in abroad, and definitely in all IITs and NITs and so on in India. I don't really know enough about whether all colleges use it. Okay, but it is a good idea to use a course number or a code for a course, and the course name and semester in which it is offered. If it is offered in both semesters, you say both 1 and 2, or if there is summer term, if I say 1, 2, 3, number of credits for that course, or in the case of colleges, maybe marks, maximum marks for the course. Prerequisites: in order to take the course, what other courses must have been cleared? Like it could be other course numbers which are prerequisites, and before you take these other courses, you cannot take this course. Okay, so the prerequisites is one more important part. So some entities depend on one another. Okay, in fact we saw this. See, the here teacher and course are two entities which depend on one another. So they will depend on entity vendor, and entity items are related as vendor supplies items. These relationships are described by entity relationship diagram. So it's a graphical method, as we have been always pointing out. A picture is worth 100 words. Okay, so pictorial representation is a very easy way of documentation, a good way of documentation, and also gives you an idea about what attributes are being used, and in other words, what are the entities which are being used, what are the relationships which are being used, and also later on we will see that what are the attributes of an entity. So here diagram, the normal what I would say, the notation which is used commonly is to have a rectangle to show an entity and a diamond shaped box to show a relationship. So vendor, and then within that particular box you write the name of the entity and name of the relationship. So vendor supplies items. So entity is vendor, items is an entity, and the so that is what the entity is a vendor, the entity, another entity is items, and the relationship is supplies. Similarly, order is an entity, vendor is another entity, and placed with, orders are placed with vendor. This is another example of the of a entity relationship model. There is no algorithm to identify entities and relationship. In other words, program you can write to detect automatically what are entities and what are relationships. Obviously, because they are checked, they are obtained from, you might say, requirement specification, which are normally stated in plain English or whatever language. And so you should be able to interpret that language and design the particular identify what are all the entities and what are all the relationships. So when a word statement is used to describe an application, nouns are normally entities and verbs are relationships. In fact, I told that earlier, but I am repeating it. The nouns are normally entities and verbs are relationships. Like for instance, a teacher teaches courses, students attend courses. Okay, students is an entity, attend is a verb in that, it is a relationship, and courses is a noun which is another entity. teaches courses, students attend courses. So these are two simple examples of how to detect the noun class. Noun class, there are two noun classes in this case, you might say, and then there is a verb which connects these things. Okay. One can of course pick points in my grammar, but the important point is that the connection is through a verb, and these are normally thought of as noun phrases. One entity may be related to many other entities by multiple relationships. Like orders are placed for items. So order can be order number, order date, and vendor is vendor code, name and vendor address. See, normally in the entity relationship diagram, you put the entity down, and on the side you write down the attributes of that entity. In this case, I have just given two parts. Okay, well, not just to kind of economize on space. An order entity may not just have just two parts, because there is a key. Key is essential. The other things may be there, many more things may be there, but I have showed only two here. And placed for item code, item name is place for items, and order number and item code. These two are the primary the keys of this and this. So I am putting it, but later on we will kind of do a little bit of you might say refining of this, in the sense that only in certain cases you require both of them as what is known as a composite key. The two keys put together as a so-called composite key. Similarly, in this case, I used a composite key of order number, vendor code and item code, and in fact it looks a little odd, because the item does not occur either here, either unless order number has also got an item code in it. Okay. So the item code appearing here is not actually, the reason it is appearing is that in this entity attribute, item code must have been there. So I am illustrating the point that just don't blindly put something in the relationship which does not occur in the attributes of the two entities. Normally the relationship will have these two keys, and also mostly something which has like for instance quantity ordered. See, the order number also will have quantity ordered in it, and price per unit also will normally be there. So normally the relationship also would really have this what is there in that in the entities. Okay. So because of the, to illustrate that, don't do it blindly. You kind of look at it somewhat carefully and do the proper job of writing it out. Of course, putting it as something like what I have done here is not all that good, because it occupies space. It's better to kind of put it in a row, which is what I will do later on in this module. So I think we'll continue from this point onwards and look at in greater detail in the next lecture.